Find A1, the annual cash flow. In this problem, we are provided a cash flow diagram which includes a negative annual cash flow, A1, lasting for years 1 through 17. There is also a positive annual cash flow, A2, lasting for years 18 through 21. We also know the nominal interest rate equals 7.5%, compounded quarterly. In this problem, we know the annual cash flow A2 equals $10,000 for each of the 4 years, and we're asked to find the annual cash flow A1, and we should assume that there is a net balance of $0 in the account at both the beginning and the end of the cash flow diagram. To solve this problem, we'll first convert the positive annual cash flow, A2, to an equivalent future value at the end of year 17. Keep in mind the arrow size for F17 is not drawn to scale. Next, we'll convert F17 to a present value P using F17 and the appropriate discount factor. Lastly, we'll convert P to the annual value A1. Take note that we added a negative sign to this third equation to account for a negative annual cash flow. The value of N equals 4 for the first equation and N equals 17 in the second and third equations. The effective interest rate is the same for all 3 equations and equals 1 plus I over m all raised to the m. In this equation, I represents the nominal interest rate, 7.5%, and m equals 4 because the interest is compounded 4 times per year. This makes the effective interest equal to 7.714%. Next, we'll combine our 3 equations into one single equation, which will solve for variable A1. This equation is the product of variable A2, which is $10,000, and 3 discount factors. We'll first compute the discount factor, which converts the present value to an annual value for the following 17 years. After plugging in variables I effective and N, this discount factor equals 0.1491. Next, we'll compute the second discount factor, and after we plug in the known variables, we compute 0.2827. The third discount factor is again computed by substituting in the effective interest rate and variable N, and we get 3.3333. Finally, we will return to our equation for A1. Then plug in A2 and the 3 discount factors, and we compute A1 equals negative $1,405. When reviewing the possible solutions, the answer is C.